And we are live. Hello, everyone. Welcome to yet another session of Serverless Days for Nature. And I hope you people are doing good. Today, we have a new speaker with us. So let's welcome our new speaker for the day, Donnie. So, welcome, Donnie. How are you?
I'm good. Thank you, Ashwat. Hello, everyone. I know that I cannot see all of you, but I'm really hoping that you are doing really great and in good shape.
Hopefully, everyone is. And guys, I really feel that you'd be loving this particular talk today because deploying container
Hopefully.
workloads is hopefully they will. So deploying containers has been a really difficult task. So today, Donnie is going to let us know how we can ease the whole process. So over to you, Donnie.
Thank you, Ashwat. Hello, everyone. I'm super excited to be here with all of you at Serverless Day Bhubaneswar. And thank you so much for inviting me here. So, as Ashwat mentioned, that this session is going to be really exciting as we're going to discuss about containers, especially using Docker runtime and how to run container-based application with Amazon ECS using AWS Copilot. And as you know, that AWS presents several options that you can choose from for running containers in the AWS ecosystem. So in this session, we will discuss how you can run containers using Amazon ECS and AWS Fargate with a twist, and that is using AWS Copilot as the tool for building and operating. Now, hopefully that you already know a bit about containers and looking for a solution to improve your development with AWS technologies and tooling. And for those who are pretty new at this space, don't worry if at some point you encounter some terminologies or concepts that you don't understand. You can drop your questions in the provided comment box, and I will answer your questions if the timing is possible at the end of the session. Okay, so this is what we have for today. You are a developer. You have built your applications written in Go language, Python, TypeScript, or something else, and your code is working perfectly. And you have made sure that your application includes the dependencies such as configurations and other libraries that your application needs so it can run properly. Good job. Now, you want to have an immutable artifact where you can use it to run your application basically anywhere. And at this point, you want to deploy your application in the AWS cloud, probably in a testing environment so your customers can try how awesome your application is, right? And and to apology for that. And to move forward, you know that you need to deploy your application with one of the most wonderful service for containers from AWS, and that is Amazon ECS. I will share with you why I love Amazon ECS in a short while. But at this point, you know that you need to deploy your containerized application to Amazon ECS. Using Amazon ECS is easy. You know that already. You know how to create cluster, you know how to create tasks, and how to integrate with elastic load balancing. And you finally roll out your application using Amazon ECS. Your customers love it. They are spreading the word that you have an amazing application. That's super awesome, right? And so your app grows, and as it grows, you are wondering all of these questions. How do I set up and deploy my services easily? And as your application grows, you need to add more features, right? And it strikes you, oh my, I need to create a different environment. I need to separate a testing environment for internal team and another environment just for experiment. And I cannot break production application. How? How can you collaborate with your team and how you can scale your service? How do you add and manage more services? How about different databases for different environment? Right? And you just sit in front of your monitor knowing that there are so many things to do. But how if I told you that there's one tool that you can use to do all of these activities? And guess what? That's why I'm here today talking about AWS Copilot. So in this session, I'm going to take you into a journey where we can answer all of these questions by using AWS Copilot as our tool. And hopefully, by the end of this session, you're going to be fully amazed with the features in AWS Copilot, and you can use all of the knowledge that you get from this session to deploy and operate your application, right? My name is Donnie Prakoso. I'm a senior developer advocate covering for ASEAN, working for AWS. I'm based in Singapore. I have more than 16 years in software development and sysops. As for my professional experience, I started in banking industry, then moved to telco industry and startups. My specialization is microservices and all sorts related to that, like containers, serverless, and design patterns. And I love coffee so much. So if we happen to meet each other in the future, let's grab some coffee together. Okay, so that's my introduction, and let's start this session. So here's the structure of this session to give you a quick overview of what you'll be getting into. Assuming that you already work on containers, I'm going to straight to introduce you to the container landscape on AWS. And once that we have finished covering container landscape on AWS, we're going to move forward to the main segment, and that is how you can build and operate your containerized application with AWS Copilot. I will take you through with a step-by-step demo so you know how to deploy a container from your local development into a production-ready environment. And this is going to be a live demo, so just be aware if there's an awkward silence waiting for the operations to be finished. That's what's already intended in this session, okay? As you know that running a single container is easy. Once that you have containerized your application into an immutable image, you can easily run it with Docker run. That's it. But in reality, we often need to deploy more than one container. It could be tens, hundreds, or thousands containers that we need to deploy. That's in real life, right? And especially for those who are building applications with microservices approach, this is very relevant to your situations. Now, when it comes to this kind of situation, there are two things that I like to emphasize. The first thing is that you need a mechanism for scaling. And it's supposed to be a fast scaling from 1 or 2 containers to 100 containers in a short period of time. Second, you need to know and place where the containers will be allocated in your infrastructure resources. And you might ask yourself, how do I manage all of these containers, right? And that's exactly the role of container orchestrator. Essentially, container orchestrator is a software that will help you to manage everything for your containers, including the lifecycle. And this is a really good segue for me to take you to the next segment. And that is AWS services that you can use to do development and deploying at scale for container application. And one of the most important services that you will definitely need when you're building application with containers is a repository to host your container images. And for that, you can use Amazon ECR. Amazon ECR is a fully managed service that makes it easy to store, manage, share, and deploy container images as artifacts for your application. And one significant advantage of using ECR is that it has deep integration with Amazon ECS. And what that means to you is that by using ECR, it will make your life easier to deploy the container with Amazon ECS or other container offerings from AWS. And this is very useful in the development experience because with this seamless integration, you can create and build your container image with the Docker CLI, push your image to Amazon ECR, and deploy to Amazon ECS. Now, moving on to the service that you can use to run your containers, and that is Amazon ECS. Amazon ECS is a container orchestration service that can help you to deploy at any scale. So when you define a service as a control plane container orchestration, the thing you need to consider is the level of reliability and integration of the service into other services. Why? Because it makes it easier for you to manage your application as a whole. Amazon ECS has networking features at the container level and supports Docker networking and integrates with Amazon VPC to provide isolation for containers. And this gives you control over how the containers connect to other services and external traffic. And in addition, ECS also provides several scheduling strategies that place containers in your cluster based on resource requirements. And using the scheduling strategy provided, you can schedule batch jobs, long-running applications, and processes that runs daemons. And ECS provides you a managed control plane to run containers. And the next thing that you need to know is which competing options that you like to run. Now, talking about containers, we also need to get to know the hosting aspect, or in short, the resource pool on which our container will run. Here you have two choices, You can use Amazon ECS, Amazon EC2 or AWS Fargate. With Amazon EC2, you have the flexibility to define CPU, memory, storage, and networking performance for your resources in the form of a VM or virtual machine. And you can also use AWS Fargate, which is serverless computing, where you don't have to handle VM resources manually because it's running in serverless mode, and AWS Fargate will take care of it for you. Amazon EC2 is perfect for you who need granular control over your environment. And AWS Fargate is more suitable for those of you who want to focus more on your application development and you don't want to think about the operation to handle the VM. Now, with these two options, you might ask yourself, which one should I choose? EC2 or Fargate? Now, at this point, you need to consider how much control you need over the computing infrastructure that underlies your cluster. In some cases, you may need complete control with Amazon EC2, such as type, size, to pricing model. It could be on-demand, reserve, or spot instances. But in other cases, you may not need to think about infrastructure, so you can focus on application development instead of system operations. All you want is to specify the container image that you want to run, determine the appropriate resources, networking, and storage, and let ECS run it with Fargate. And that's really convenient. Now, diving deeper into AWS Fargate, so AWS Fargate is a technology you can use with Amazon ECS to run containers without having to manage Amazon EC2 servers or clusters. With AWS Fargate, you no longer have to provision, configure, or scale virtual machine cluster to run containers. And this eliminates the need to choose a server type, decide when to scale your cluster, or optimize cluster packing. When you run tasks and services for Amazon ECS with Fargate, this is what you need to do. The first thing that you need to do is to package your application in the form of containers like Docker image. Then second step is that you need to determine the CPU and memory requirements as well as networking. Then you need to define the IAM policy. And finally, your app is ready to run. It's so easy. You don't need to think about or manage infrastructure because Amazon ECS will integrate with AWS Fargate according to the predefined task definition that you already defined. That's amazing, right? Each Fargate task has its own isolation limit. It does not share a kernel, CPU, memory, or network interface with another task. And using AWS Fargate also gives you cost advantage because with resource-based pricing, you get a cost-effective way where you pay based on how long the container runs, based on how much CPU and memory that you have defined. And as mentioned before, deploying a container in localhost like your laptop is pretty easy. You only need to execute Docker run. But the real challenge is when you are trying to run your containerized application for production environment. From building, deploying, and operating, these are three processes and the entire workflow for running your containerized application. And also that you need to understand and implement a set of best practices. It's not only about running the application, but the entire workflow to build, deploy, and operate your application. Now, the problem is the current existing solution out there either help you provision the infrastructure or they help you monitor and troubleshoot your services. There is no single tool yet to achieve all of them. And these are some of the questions that I already flashed earlier in the beginning of the session that you might be wondering when it comes to running container application. For a starter, deploying application. It is a really basic question, but it's totally legit. And apparently, to actually answer these questions requires some sort of knowledge on how services work and how to integrate one service to another. Once that we have deployed the application, we also need to have visibility on how everything works. Logging and monitoring are two main things in observability that we need to have to ensure our applications work properly. And when you grow, you definitely need to add more features. And more than often, more features require more service integration. Then we definitely don't want to interfere our production applications with our test release, right? So we need to make sure our application work in different environments, separate environments. And not to forget about CI/CD, especially those who are working with microservices again. because deploying tens to 100 services are something that we need to automate. And lastly, how to clean up if we don't need the application anymore. So this is a non-exhaustive list of questions that depicts real-life problems. There are many more of them, but for this session, let's stick with them. And that is the particular reason why AWS built Copilot. It's a single tool to address these three challenges around developing containerized applications to simplify building, releasing, and operating application. AWS Copilot is a command line interface that you can interact in your terminal, which enables you to quickly launch and easily manage containerized applications on AWS. When I mention about easy, it's literally easy. I will going to show you how in the demo. And AWS Copilot provides a simple declarative set of commands, including examples and guided experience built in to help you deploy your applications quickly. So when it comes to deploying and operating your application with Copilot, Copilot automates each step in the deployment lifecycle, including pushing to registry, creating a task definition, creating a cluster, down into the details of the operational logistic. And one of the advantages of using Copilot is that all AWS best practices are embedded into this tool, so you can have scalable, reliable, and extensible applications with less effort. Now, before we go down into the Copilot features, let me show you how you can install and use Copilot quickly. So there are two ways on how that you can install Copilot. You can use Homebrew or you can do it manually. To install AWS Copilot with Homebrew, you simply execute this command. And once that you're done, you can check the installation by executing the Copilot -help. In some cases, you like to install Copilot manually, and you can execute commands specific to your operating system to have Copilot installed. Now, to get more information about Copilot, Copilot team already has a nice documentation for you to get started. You can read the documentation here, or you can go to the GitHub repo. Okay, now with the installation out of the way, let's talk more on its features. So, what does building an application with Copilot looks like? With Copilot, you only need to type Copilot in it, and then the CLI start guided prompts if you want a service that's internet facing behind a load balancer, or you want it to be private with Backend Service, and then all the resources are generated from that for you. So you don't have to worry about wiring resources with best practices because it's already been covered by Copilot. And the most important thing is that Copilot is built with convention over configuration and purposely built to help you in your entire developer journey, so you don't have to use a different tool. So if you have your applications and Docker file ready, Copilot will process the Docker file and will prompt you which one you like to use for your service. And finally, if you need to actually gain control of the resources and need to use some resource that's not integrated within Copilot yet, you can leverage our add-ons features, which allows you to write CloudFormation template directly so you can add any other resource to your service. It's easy, it's simple to use, and extensible, which really suits for us developers. And when it comes to running container applications, it's not enough to only have applications and provision the required resources. We also need to think on how we could automate release process from local development to any kind of environment that you need. Now, with Copilot, you can deploy your service manually by just running Copilot deploy to a particular environment, or a better way to do that is that you can run Copilot pipeline in it to set up a continuous delivery pipeline. And if you have a different environment for your applications like testing or production, or even separate accounts or regions, you can run Copilot env in it to choose whichever AWS profile you want your apps to run. And lastly, once that you have completed build and release process, you will need to monitor your applications. And for that, Copilot provides operational commands. With Copilot, you can also run on-off tasks, and this is really handy because it can be pretty much anything from populating the data to load testing. So one of my favorite features is how Copilot makes it easy for us to do logging. You can run logs to get all information printed out by your applications, and you can also get the health status of your applications. And it's amazing because everything is in one single tool. Now, To have a better understanding on features that Copilot has, let's jump into a demo where we're going to deploy a voting application step by step. So in this demo, we're going to deploy and operate a voting application. So what you see on the screen is the end result. It's a voting application that lets you to vote which IDE you prefer. Right. So this is how it looks like. This is a really simple application that's going to give us like a couple of options of IDE, and then we need to click vote on each of these options. Right. And now let's switch to the diagram. Now, this is the diagram that explains the overall voting application. So the voting applications consist of two components, voting web and voting API. Now, voting web serves as the dynamic website, and voting API handles all business logics, and that includes listing all options and process a vote request. Now, to do that, the voting API has several endpoints for voting web to call. So there are three endpoints, and they are for health check, right? So you can see on this one, if you can see my cursor here, this is for health check. And then options to get with the get method to get all polling data. And finally, /API/options, but with post method with to vote which IDE that you prefer. Right, so it's a simple applications with a voting web. This is a dynamic website, and it's going to call an AJAX call to voting API, and then there are three kind of endpoints. There are two kind of endpoints in which this voting web needs to call. The first one is to get the data, which is going to get from API options here with method get, and then if you like to post, and then you need to you want to vote, then you need to use the post method to the same API endpoint. Pretty easy. Now, the first step that we're going to do in this demo is to configure Copilot to work together with our applications. And to do that, we need to run Copilot init. Now, Copilot init will ask some questions, then it will set up an ECR repository and giving us options to deploy. If we opt to deploy, it will create a new environment, complete with a networking stack and roles, build your Docker file, push it to Amazon ECR, and deploy your service or job. And once that we have our application successfully deployed, we can check the status using Copilot App Show and Copilot Service Show to get more details. All right, so let's do that. I'm going to prepare my environment for a while. Okay. I hope that you can see my terminal. Is everything good, Ashiwat? If you can give me a cue if it's good.
Yes, Donnie, everything's good.
Okay, cool. Okay, so before we dive into deploying these applications, let me show you the overall applications, how it looks like, so you get a better understanding on how I structured this demo. So I'm now need to go to this repository, this folder, voting app. Yep, so you can see there are three folders here. We have app, which is the API. We have web, which is the dynamic website, and task, which we're going to use to seed our database, but that for later on. So let me open up the most important part, which is the API. Okay. So this application is written in Go language, and you can see that I'm using the AWS CDK for this. So this is the structure of the option. So we have name of the options, we have vote ID as an identifier, we have votes, total of votes, and also the image, which is the URL for the image. And you can see that I have another structure, which is the config. And this config is actually going to get the files within the folder. So if I go here you can see that I have this nice simple configuration, and that is for application port. Okay. Okay, so and then these applications, it has let me go to the last one. Okay, so it has three endpoints. We have API options with method get, which is going to list down all the options from the DynamoDB. And we have this API options with method post, which is going to process our vote and then going to update into the DynamoDB table for respective item. And then we also have slash, which is the health handler, just to make sure our applications working properly. Now, if we go to the options handler over here, you can see that I'm just like simply doing a query from the database. Let me show you how. This is how I'm doing. So it's going to get from the DynamoDB, get all this data, and then send it back to the client. And then for the vote applications, you can see that I'm adding, this is the vote function. You can see that I'm adding this increment into the votes. So it's going to add +1 from the previous record whenever it gets signal that a users prefer this option. Okay. And this also the Docker file. This is going. I'm using like a multi-stage build. First, I need to compile the application, and then I'm going to copy over the main file and then put it into the image that I'm going to deploy. Right. So at this point, you see that there's no like a specific routines that I need to embed into Copilot or Amazon ECS. Everything that we have is totally agnostic, and if we go to the another application, which is the web one, I'm using Gorilla here, which is a really cool tool, and then it's simply like surfing the static websites, static file templates from HTML I have provided here, and then it's simply like surfing that, and then the index.html, it has a nice Ajax call here. If you go to the last part, you can see that it has a calling the options, yeah, to these API options, which is the API that we're going to deploy, right? So now you understand the overall structure of this template. So what we're going to do now is that we're going to deploy this application. And to do that, the first thing that we need to do is to initialize the application. And then the first question is, would you like to use one of your existing applications? This question is only appears here because I've already deployed other applications. So I'm going to choose no. So what would you like to name your applications? I'm going to use serverless day bebaneswa Copilot. So SDB-Copilot. Right. So now it's going to create the infrastructure to manage services and jobs under applications with the name SDB Copilot. Now, I'm already mentioned it to you. There's going to be a couple of awkward silence, right? So I'm going to switch back and forth between this demo and also the presentations just to fill that gap. And so what it's going to do is the Copilot is going to create the infrastructure. And the way it works is that this Copilot has this terminology called application. And within the applications, it could has like a services, it could has tasks, it could has job and other things. So but the umbrella that is going to create is called the application, right? So we're going to wait for a while until it's finished. Meanwhile, let me show you. Okay. Oh, it's done. Phew. Okay, so now we already have this Copilot in it. Now what we're going to do is now to create a new service, right? But before we deploy the service, that we need to create the environment first. And why that we need to create the environment? Because we don't want to interfere, like for example, production applications. So we want to have a nice separated and isolated environment for our applications. So we can do anything that we want, like probably that we want to enhance a new features and we want to test it out without affecting other applications in other environments. And to do that, we need to initialize the environment. We do it by executing Copilot env init. So I'm going to name it as a test, and then I'm going to use the default. And here that you have a couple of options. You have three options that you can use default. You can use the use the default, but you want to have manual configurations for the CRD ranges. And you can also import the existing resources. Right now, I'm going to use the default. Yeah. So what I'm going to do now is going to linking the account and region episode is one to application SDB Copilot. So it's going to prepare everything in my account. Yeah. Now, while we wait for the Copilot to finish its task, so let me show you a couple of basics about Amazon ECS, because it's really, although that Copilot already covering all of this stuff, but I feel that I need to share with you the foundation of Amazon ECS, so at least that you understand how the Amazon ECS works to run your container application. Now, so let's start with cluster, right? An Amazon ECS cluster is a logical grouping or tasks or services. Now, when you first use Amazon ECS, a default cluster is created for you. But you can also create multiple clusters in an account to keep your resources separate. And then there are tasks and also services. But let's talk about tasks first. A task is an instantiation of a task definition that is running in AWS Fargate. So you can think about a task definition as the blueprint for your task. You need to specify the name of the task. You need to specify the revisions, container definitions, and volume information. And finally, that we have services. So an Amazon ECS service enables you to run and maintain a specific numbers of instances of task definition simultaneously in Amazon ECS cluster. If any of your tasks should fail or stop for any reasons, the Amazon ECS Service Scheduler launch another instance of your task definition to replace it in order to maintain the desired number of tasks in the service. So it's really simple. We have tasks, we also have service in which they are both running on AWS Fargate in this context, but you can also have the other options, and that is by using Amazon EC2. But if you understand these four terminologies from cluster, task definition, and also service, then you already know like the foundation of Amazon ECS. Okay, so we have talked about tasks and services, and we have explained some of the differences between them. But this is common questions. Which one do you use for your particular workload? For on-demand workloads, the ECS Task Schedulers is the best option. It is ideal for workloads that need to run once or at recurring intervals. You can think it like a batch job or short-lived operation. Now, for long-running workloads, the ECS Service Scheduler is used. It provides health management features to ensure workloads are up and responding correctly. The ECS Service Scheduler also supports the scaling up and down of workloads and has an awareness of availability zones. Now, these features make it ideal of workloads that need to be highly available and scale to meet changes in demand. Now, it's still creating. Now, when you saw me executing this Copilot init, not now, but later on, you will see that there are a couple of options available for you to choose. Right? They are request driven, which is basically creating an app runner service, and an app runner is a new service from AWS that you can use to deploy your application easily. And if you want to know about this, how App Runner works, just to give you a quick overview, you can visit my YouTube channel, and there I have a specific video on how to deploy web application with AWS App Runner. Now, just want to give you on how it works. Let's say that you have a simple application that you want to deploy with or without Docker file. You can use AWS App Runner, and App Runner makes it super easy to deploy application, like seriously. And this is something that I can see that in the futures that more developers are going to use App Runner to deploy a couple of services, like a simple application that they already built the applications, and they just looking for a simple deployment. They don't need like a really large scale of requests. Then they will go for App Runner. It's really cool. I would suggest you to look how it looks like. Okay, so now at this point, we have our test environments already been completed, right? So now what we can do is that we can check the environment by using Copilot environment show. And we don't have any services yet, right? You can see it is still empty, yeah? And then what we're going to do is that we're going to create the service. Let me check. Yeah. And to do that, what we need to do is to execute Copilot service init. Now, this is what I mentioned. There are three kinds of options available whenever you want to deploy your service. There's a request-driven web service, which is the App Runner that I just mentioned. The load balance web service, Internet to ECS on Fargate, and Backend Service. I'm going to cover those two later on. But for now, let's do this demo first. So I would love to have a load balance web service. What do you want to name this load balance web service? So I'm going to put it name as SDB web. Yep. And then you can see that the Copilot magically identify all those Docker files that I have in this folder. So I'm going to use the web/Docker file. Yeah. So what it's going to do is that it's going to create the ECR repositories for this particular service. So we're going to wait there for a while. And then we need to go back to our slide. Now I mentioned about this load balance web service and also the backend service. So we're going to try to distinguish between these two, because more than often that you're going to use these two options. Now, the first one is the load balance web service, and essentially that load balance web service is an ECS service running tasks on Fargate with an application load balancer as ingress. You can see that there's an ALB in this diagram, yeah? And the entry point is the ALB, which is going to distribute the requests coming to your applications. Now, this option is suitable for HTTP services with steady request volumes that needs to access resources in a VPC or require advanced configuration. Now, this ALB, it needs a listener, right? And to check the connection request, it uses the protocol and port that you configure. Within the listener, it has listener rules. And each listener has a default rule, and you can optionally define additional rules. Each rule consists of a priority, one or more actions, and one or more conditions. And you can add or edit rules at any time. The rules that you define for a listener determine how the load balancer routes requests to its registered targets. And lastly, that we have this target group over here. Now, to be able sending the request to the correct target, we need to have a target group. And this load balance web service is suitable if you need a public-facing service, which means it can be accessed publicly. And you don't need to worry about load balancer and scaling, as you can easily define the desired capacity with Copilot. Okay, so let's see our demo. Cool. So now we have this this service. It's not deployed yet. It's just created the manifest. Now, if you notice, there's a new folder created by Copilot, and that is Copilot folder Copilot here. And then inside, there's a service called SDB Web. Now let's see what we have inside the SDB Web. We have this manifest file, and this manifest file is what AWS Copilot is going to use to create the required resources. Now you can see that we have this name here, and then we have this HTTP here. This is the path. If you want to change the path, you can modify it here. And then you have this image. This is I already mentioned that's going to get from the web folder / Docker file, and with port 80. And then you can also define the CPU memory, and also count number of tasks that you want this Uber to be running in the service, right? And then you can also define the variables. You can also define the secrets and the environment variables. But we're going to cover that later. And once that you have this manifest file, let's say that you don't need to change anything. What you need to do now is to deploy your service. You need to Copilot service deploy. You can do things. You can explicitly use the flags like name SDB web, and then also the environment. But the simple way, if you are new to Copilot, you can just execute Copilot service deploy, and it's going to automatically deploy to the default target. Default service, and also the default environment. Right, so what we're going to do is now is going to create and deploy the service web. Now, we're going to wait a couple of minutes again, all right? And meanwhile, let's go to our slide. Now, besides the load balance web service, you can also have the other options, which is backend service. Now, in contrast, if you want a service that cannot be accessed externally, but only from other services within your application, you can create a backend service. Now, with backend service, you won't have any internet. Sorry for that. With backend service, you won't have any internet-facing service, which means that you cannot access this service publicly. Yes, you cannot access this service publicly. Wait, what? Why do I need this? So let's assume that you're creating a microservices. One of the most commonly used pattern in microservices is to have a centralized gateway as the only public endpoint. Now, the rest of services, it could be tens or it could be hundreds, they only need to connect internally, and they don't need any public access. So if you want to limit the exposure of your services, you can use backend service. And then the question is that, okay, so I know that backend service we cannot have any access publicly, but how can all these services can communicate internally? And that's why there's a service discovery element here, if you can see my cursor. So service discovery is a way of letting services discover and connect with each other. So technically, each service you create is given a private address and DNS name, so they can communicate without ever leaving the local network and without exposing a public endpoint. And it's done by leveraging ECS feature called ECS Service Discovery. Okay. Now let's see again if Copilot already finished its task. I think I've been talking too long. Okay, so it's still creating the infrastructure for the SDB-web. Now, if you're wondering what happened in the background, you can also check. Okay, so I lost my. Okay, I need to go back here again. So if you're wondering what happens in the background, then you can check on the CloudFormation. You can see that this CloudFormation is currently create all these requirements for us. And then you can see all these events and also resources here in these CloudFormations. And yeah, so that's how this AWS Copilot integrates with Amazon CloudFormation. Okay. And yeah, so let's talk about this Copilot CLI. So I know that I've already mentioned a couple of things like in advance, like service discovery and all those stuff. Everything is already provided here in this Copilot documentation. There's a nice concept that helps you to understand how everything works with AWS Copilot, and also that I also need to mention that it also Copilot also makes it easy for us to store the credentials. You can put like a secrets here with Copilot. Essentially, it's going to use the SSM here. Let me check if there's any secrets here. Yes, there's a secrets here. So now, because secrets is something that probably that you want to add like a database credentials that you can put it as a secrets, and this is really convenient because you now can use Copilot to manage everything, starting from your applications to your secrets, without leaving your terminal. So that's really convenient. Okay, so now we have our web deployed. So if I go to this URL, you can see that it's deployed properly, but it's not running properly yet because we haven't deployed our API, right? But at least now we know that it's deployed properly. Now, at some point, you might want to get the logs of your application, right? Now, what you can do is that, let me check. Yes. You can do that by executing Copilot service logs, and then you need to explicitly name your application that you want to get the logs. In this case, it's SDB Web, and then also one particular important flag is that you can follow the logs. You can see it here. Nice. So we have deployed. We can have the logs, everything using AWS Copilot. So it's really good. Now, the next thing that we need to do is to create the API. And to do that, so for example, in the future, probably that you want to add another service. And how that you can do that? Just repeat the command again, which is this Copilot service init. Yeah. And then you can choose like load balance web service or backend service. In this case, I'm going to choose load balance web service because the web is going to connect to API publicly. And then what I'm going to do now is going to name the API SDB-API, obviously. And then I'm going to choose the app/docker file, which is where the API resides. And yeah, it's going to create the ECR repositories for Service SDB API, and it's going to create the manifest file for the API service. Right. Okay. So going back to the application, to our presentation. Yeah. So so I hope that really makes sense to you, and now you know how to choose between these two services, between the load balance web service and also the backend service. Basically, that if you want to have your applications exposed to internet, just choose load balance web service. And then for this, the backend service is usually if you have like a couple of microservices that you don't want to expose publicly, and you can connect with them internally. So that reminds me. So now it's already created the manifest file. So let's try to open the manifest file now. Now, for after you create the manifest file for your service, the first thing that you probably want to change is the path. Why? Because that really depends on your applications. But for example, that my web is going to call /API, and that's why I need to change the path to API here. Yeah. Now, what I'm going to do is that I'm going to deploy the API. Now, because we have more than one service listed in this application, now we can choose with, and that's I'm going to use the SDB API. And we didn't get this kind of options because previously there was only one service, and that was this SDB web. Okay. Yeah, it's going to create the stack for this Copilot. And yeah. Okay, so meanwhile, I'm going to open the terminal and see if there's any questions from all of you guys.
I guess there aren't much. Maybe
If there are
everyone's
much,
new
that's
to.
fine. That's
Maybe
fine.
everyone's new as I am with this particular area.
Okay, so what do you think, Ashwat?
I think it was pretty good. The doing hands-on demo was pretty helpful, to be honest, because
Mm.
if it was a pre-recorded session, you wouldn't know if
Yeah.
something happens in the middle of the demo. How would you work around with that?
Yeah,
So
so
far,
that's a
so
really
good.
good question. Yeah. So, but what I found is why I love AWS Copilot is it's really intuitive. Like I mean, yeah. To be honest with you, as a developer, we found like a couple of problems, especially when it comes to deployment, right? And what I love about AWS Copilot is that everything is so transparent. Like if there's something happen, then you only need to check to the cloud formation, the stack sets, and then you can check what is the error there, and then you just can finish resolve it, the problem, and then you just can redo the operations in AWS Copilot. So yeah,
Uh, uh,
yeah,
there was one thing that was coming up to my mind. It was more like
yep.
if somebody had CI/CD pipelines and able to deploy the containerized application, how would Copilot come into the picture over there?
That's a really good question. So basically, Copilot has its own configuration for this CI/CD. So so it's going to be executed by AWS Copilot. So whenever you push any changes, it's going to deploy it directly. So that's
Okay,
how it works. But it needs to be tied by the AWS Copilot.
that
And
makes
let me
sense.
show you. Yes, and then let me show you. Oopsie. Um, do I have another? Okay, so let me check now. Which one is that? Okay. So that's a really good question. And then let me show you on the you can set up pipeline. I'm not going to execute this now. I just want to let you know how that you can do that. So all you need to do is just to execute Copilot pipeline. Oh, sorry. Uh, sorry, I need to log in. Boop, boop.
That happens.
That happens. Okay, so all you need to do is just to execute Copilot pipeline here. And then it's going to give you some comments like init if it's your first time to setting up the CI/CD, if you update the configurations, or you even want to check the status and show all these resources. And yeah, everything is in one single tool.
So this will be done using code deploy and I'm sorry, can you
Exactly.
fill it? Okay,
Yes, correct. So it's going to use the code pipeline for that.
that
Yeah.
makes sense.
Yes. Oh, now it's already deployed. Now let's see what happens if I go to this link. It's going to be a problem. Wait, sorry. Bad gateway. And then you know what? What is your first guess, Ashwat? Why it shows us a bad gateway?
Maybe the ports weren't open.
No. Other than that, another guess. I'm going to give you AWS credits if you can answer this right.
Uh, Let me think. I'm running out of guesses, to be honest with
Because
this.
I haven't set up a database yet. you know that I mentioned that I'm
Oh,
connecting this application to database, right? So that means that we need to create a database first, right? And then we can do that by executing Copilot storage init, and then we need to associate this to particular application, which is SDB dash API. And then currently there are three kind of services, the storage that are supported by AWS Copilot, and that is DynamoDB, S3, and Aurora Serverless. And then what we like to name this DynamoDB table. So let's say that I want to name it as serverless day 14 DB. And then the partition key is supposed to be, Fort ID, I believe. Yes, let me check again on my code. Yep, that is right. And data type is this key is a string. So you can see that we are starting from scratch for the database. Nope.
so are we creating one on the fly?
Yes, exactly. That was
That's
fun about
interesting.
having live demo, right? Okay, so what I'm going to do now is that we're going to deploy the Service API again because now it's already integrated with the database. Now let's go check the manifest file for this API. Right. Sorry, not this one. Okay, so this is really good one. So if you add some kind like add-ons like AWS services to your Copilot service, it's going to create another folder called add-ons. Yep. So it's really cool, and it's being done by the Copilot. And if I go to this YAML, you can see this is a basic CloudFormation template. And what it means is that you can actually inject your applications with your own custom CloudFormation template. So that's really nice. So what I'm going
Donnie,
to do,
I may ask you what's
yep.
cloud formation now because I'm pretty new with AWS. So
Oh, really? Okay, so let me show you what is CloudFormation is. That is really good questions, and I'm going to cover that once that while I'm deploying my API. Yeah.
yeah,
That's a really good time feeling. Thank you, Ashwat. You just saved me.
you're welcome.
Okay, so I'm going to deploy the Service API, because now it's already integrated with Amazon DynamoDB. Yeah. So yeah, so it's going to rebuild the Docker image again, and then it's going to propose the infrastructure changes and everything that you can see on CloudFormation. Now, what is CloudFormations? Now, CloudFormations is a service from AWS that helps you to speed up the cloud provisioning with infrastructure as code. So that means that the YAML file that you just see earlier, let me check. So this is 13. Okay, so let me go to so this is one example of AWS CloudFormation. Sorry. If we go to this DynamoDB, just this one, so you know that AWS has a lot of services, and one of them is called Amazon DynamoDB. Amazon DynamoDB is a NoSQL database from AWS, and what it means, what this manifest means, is that we are going to create a DynamoDB table with all of this information. Like for example, this is the table name. This is the attribute definitions, which is I'm using Fort ID. And then this is the key schema. And why AWS CloudFormation is really important for everyone, in particular who are using AWS, but infrastructure as code in general, is that by having these kind of templates that you can have your machines to interpret this and provision all of this into the resources. In this case, it's Amazon DynamoDB. But how say if that you want to create an EC2 and you don't want to do like a click to go to the console and click manually, and you can use this kind of manifest to build your own EC2 or even the AWS Lambda with AWS CloudFormation. I believe that you already had a session with Eric.
Right.
Yeah, right. So SAM. So I believe that he mentioned about SAM template, and SAM templates is a really cool stuff that is actually the abstraction layer of serverless applications on top of AWS CloudFormation. So that's
So that
how it
makes
works,
sense.
man. Yeah,
So it's more like you can use this YAML templates to what we say recreate the resources in a different subscription within a few clicks.
true. Yeah, and then you don't need to click manually again.
Right.
Or you only just need to run this template, and then you have a repeatable resource provisioning anytime that you want. So that's really
That
cool.
makes sense.
Yeah. So
So
yeah.
if someone's from Azure, then it's more similar to
Mhm.
ARM templates, if I'm right.
Probably. I'm not aware of it, but basically the infrastructure as code is going to really help us. And if any one of you are new to cloud computing, I really suggest for you to see to AWS Cloud Formation, because that's not going to. It's probably that it has a slightly learning curve at first, but for the long run, you will gain more benefits. Yeah.
So Donnie, one more question
Yes.
from my end. So how important is it? Like if you're a developer and most of your work is around just adding features and committing all your changes inside a repository. So how necessary is it for a developer to know about cloud formation on the long run?
Oh, that's really good questions. So the way I see it is that now, if anyone aware about the terminology of DevOps, is that it's the culture of the organization, is that the set of best practices on how that we develop applications, but not only developing applications, but also operating the applications. And more and more, I see that there's a really the lines now, like there's an overlap between dev and ops, especially when it comes to infrastructure as code, right? I don't say that developers need to know everything about SysOps, but at least they know a couple of them, like how what or what kind of the properties, like for example in Amazon DynamoDB table. And there's another cool thing that I would like to show you. And this even makes the lines really thin between dev and ops, and that is called as AWS Cloud Development Kit. So AWS Cloud Development Kit is this with this essentially that you can use your own familiar programming languages. You can use Go, you can use Python, you can use TypeScript, and you can create resources from your application. That's really simple. And that means that for developers who are really familiar with the specific programming language supported by CDK, that means that they can easily create their own DevOps culture within their development workflow.
So it's like you're not constrained to write PowerShell scripts or else Bash scripts or Python
No.
script to provision your resources. You can use the
Yeah.
language of your choice.
Yeah. So this is really cool. That was something that probably that I would love to cover if there's any next opportunity to talk at Serverless Day Buban as
We'd
well.
love to have you again.
Oh, I love that. I love that kind of opportunity. But for now, let me show you how it looks like. So it's going to be a
Sure.
teaser. Let's say, okay, so this one. So this is the my bunch of EC2 that I created for my development environment. So what does it means is that I can have an EC2 right up after I execute these applications. You can see that everything is written in Python. And I define this EC2 instance here, right? And then can also add the user data and associate the Elastic IP here. And then if I execute like using the CDK deploy,
Gonna start the
it's
deployment
going,
process.
it start the deployment process. That's really
That's cool.
that's really cool. I really love CDK. In fact, that I'm not sure on how I can survive everything here without CDK.
Seems like our API is deployed.
Yes, now it's deployed. Okay, so let's check. Yeah, so it's still bad gateway. Anyone knows how? Why?
Maybe we don't have any records in the first place, or it doesn't have the permission to access the DynamoDB.
The best way to do it is to check. So we can do by using Copilot services logs, and then if you can see that, oh, there's a problem there, right? Probably because we don't set the name properly. And how to check it, how to check the name is that you can do Copilot env and then, sorry, svc and then show. And then what's going to give us is going to give us all those details about these applications in this particular environment. So you can see that we have the name is serverless day voting DB name here. Yeah.
Mm-hmm.
Right. And then, but let me check if we have oh, we have it now. Sorry, SDB. Let me refresh my DynamoDB table. So we have our DynamoDB table. Nice, right? So this is what been created by AWS Copilot. Now, what we're going to do is now we're going to check if we have this. We need to change the name because I don't think that I said it properly. App.main.go.
Maybe we are referencing to a different DynamoDB in our API.
Not really, because I use a different voting app name here, right? So I need to change it to serverless voting DB name here, and then also that one of the cool thing about this Copilot is that we can define environment variables, and that's really cool,
Okay.
and that's really easy. And how to do that is that, let me check, everything is good, I believe, yeah. And how to do that is that you need to go to the manifest file again, which is the SDB API,
Mm-hmm.
and then go to the manifest.yaml, and then go down to the bottom section that you have this environment, and then you can just edit as much as you want here. But in this case, we only need to have this AWS region. Yep, this is tests, and then oops, you got to love YAML. Yeah, and then AWS region here. I'm going to use AP Southeast 1. Yeah, and now I'm going to do again is that I'm going to redeploy the application. So that's how you define the environment variables for your application in AWS Copilot. Really easy, eh?
True that. But what if we are referencing to a centralized, key storage mechanism kind of a thing, like a key vault or something like that, where we store all our environment variables or API keys? How do we reference it from, something like an AWS Copilot? Like, how can we reference, the keys from our different service, like key vault?
Sorry, like keyboard?
Yeah. It's more of
Like,
like you store all your keys in a centralized repository kind of a thing, and if you want to access it,
oh,
how do you do that?
do you mean like a secrets, like a credentials?
Yeah, yep.
Oh, that's really good questions. So the way the AWS, you can use AWS Copilot for that, and it's called secrets. So the way it works is that AWS Copilot will add the your secrets as a secret string in AWS System Manager Parameter Store, or SSM. And from your applications, that means that you can look up from this SSM. So that's how it works. You can manage that directly on Copilot, or you can also have like a already existing centralized credentials management using SSM that you can directly have a call from your application. So you can also, so it's similar to the environment variables. The way that you can get the secrets is by adding in the manifest file. So the way it looks like this.
Okay,
Yeah. So yeah. So everything is managed in one single tool.
that's quite cool.
It's really cool. Yeah. This is my very first time like running a deployment on the fly for Copilot, and I don't want to jinx it, but everything looks good.
It's going on well.
It's going on well, thanks to you, Ashwat. So, so yeah. Any questions?
Just let me check the chat window.
Yep.
Uh, I think there are no questions, but there's
No
definitely one
question.
appreciation from Fizos. It's pretty cool.
Oh, that's my friend. Thank you, those. Yeah. So, um,
One thing I'll do in the meanwhile, I'll just share the link of the quiz so that folks can just go over there and attempt the quiz that Donnie has prepared for us.
yep.
So the winners are going to get few AWS credits from Donnie. So Donnie is sponsoring that. So if you want to play around, tinker around a bit around, AWS services, want to build some applications or POCs to just get started, have a look and feel, then get the quiz and get the credits and do it for free. Don't pay your money.
Definitely. Yeah.
I hope
So,
people do take up the opportunity.
really, yeah, I'm hoping the same because like there are four questions that I already prepared together with Ashwat, and it's really easy. I don't think that you will have any issues if you're following the session so far. Um, so I'm really hoping that you will get all those credits.
How many do we have for the graphs?
That's a good question. I do have one, two, three, four, five, but I can add another five, which is 10 then.
Just 10 now for the graphs, guys. Pick it up. All of you have a chance.
Yeah.
And we'll be updating you regarding the quiz results by tomorrow evening. So that will be 6 p.m. IST Indian Standard Time. So if you're from some other part of other part of the world, then that's the time zone you need to follow for the result. Well, anyhow, do mention your proper email addresses so that we can communicate well. Or else things happen like you give a wrong email address, and at the end of the day, even if you win it, we can't provide it to you. This actually happened, Donnie. Like we had a
Really?
session back in January. Like
Oh.
we had an exam voucher that was worth around 12,000, but due to a wrong email address, we were unable to send it, and it was just bouncing
Hmm.
back.
Okay.
That was a
Do
missed
you
opportunity.
Yeah, so that's too unfortunate. So, guys, please put your email address properly. So, this good gentleman here, he can reach out to you. Okay, so now we have this API deployed. Actually, I want to show you another one. That is how that you can do one time of task with Copilot. But in the interest of time, I'm going to skip that. So I'm going to do now, I'm going to populate this database separately, which is actually the what I'm going to do with the tasks. Yep, and then I'm going to put it here, and then I'm going to add another item again. So the task that I mentioned to you is actually to seed the database. So let me show you how it looks like. So the way task works in the AWS Copilot is that you need to have your applications prepared here. So for example, I have this task called seed database, and basically we have this main.go here, which are files that's going to get all those information from ddb.json. So if I open up this ddb.json, it's actually giving all those these items that I need to put into the DynamoDB table. Right. So basically, that you need to run Copilot tasks, and then it's going to pick up from your current folders and going to run one time of task in your environment. Okay, so now we have database, we have this web, and then let's check the API first. Let's see if it works. It works. Nice. Now, what I'm going to do next is that I'm going to open the web, which is sitting on this link, and voila, we have the options here. So, so this is a serverless voting app. You can choose two options. Let me share with all of you. Can we share the link, Ashwat?
Sure, you can share it with me in the private chat and I'll pass it on in the chat window.
Okay, dokie. So, for everyone who's still online up till now, please do vote which one is your favorite IDE. So it's really fast as well. I'm going to be fair by clicking on the Neo theme over and over again. Yeah, but joke aside, but if you see that when you vote this the options here, it's really fast. It's amazingly fast. And that if you go to your DynamoDB table, you can see that it's updated. That wow, okay, it's updated. Like there's a trend. It's NeoVim is now loose to Visual Studio Code. Okay, but apparently it's really fast, and this is why I love like a building using AWS Copilot. It's really easy to use. Everything is so intuitive, and all those helps and hints they are there in your CLI, and it covers a lot of stuff that we need to deploy our containers application. Right. So let me do one click vote again here. Oh, there's a 40 votes. I love the audience. Okay, so hopefully you can still have fun with this voting application, but I'm going to go back to this slide. So we already covered this integration with the DynamoDB, and I just want to emphasize that you can actually extend if to another services that AWS Service has by creating your own CloudFormation templates. Currently, AWS Copilot supports S3 and then DynamoDB and Aura serverless. But you can also create and inject by injecting the AWS CloudFormation template into the add-ons folder. Okay, so before we end these sessions, let me do a quick recap on what we have learned. First, to increase your development agility, you need to focus on building your products and not infrastructure. And this will help you to keep ahead in the game. If you're running containers, you can use Amazon ECS, and it's really a great option for you as ECS is used extensively within Amazon to power services, so it's tested extensively for security, reliability, and availability. You can also get benefits by using AWS Fargate, which is a serverless compute for containers. And the main benefit is that Fargate removes the need to provision and manage servers and lets you specify resources per application and improve security through application isolation by design. And with AWS Copilot, which we have seen how it streamlines the process from building, releasing, and operating our container applications, AWS Copilot is developed so that you, developers, can spend more time on delivering more value to their customers rather than worrying about the underlying infrastructure, and you can also have more time with your family. And lastly, with Copilot, you can progressively grow your system by adding more add-ons, giving you more flexibility to extend your service in the long run. You can go to this link, aws.github.io/copilot-cli to get more information about Copilot. So yeah, so that's all for today's session. Thank you for your time. Hopefully the content and demos presented in these sessions help you to understand containers offering from AWS and how you can build, release, and deploy your applications easily with AWS Copilot, Amazon ECS, and AWS Fargate. But more importantly, for you to enjoy more and having fun building applications with AWS. And if you have any questions, feel free to contact me on Twitter or LinkedIn.
Donnie is available everywhere. So you're just a message away.
Oh,
So,
we have
Suman,
Suman. He mentioned that I did some spam voting for Visual Studio Code to test the DynamoDB. Please do. I don't have any concerns at all, Suman.
and Fidos was actually asking about one more, option to be added. He wanted JetBrains in it.
JetBrains. Okay, so now it's going to be an IDE war. Guys, it's all about Copilot and containers.
So
But this is
true.
really amazing. This is a really amazing session. I love the
Thank you,
audience.
Donny, for joining in and taking some time out on a weekend. And I know it's pretty late for you. I hope you had your dinner.
I had my dinner, and nothing beats like this is really fun to have a Saturday night coding with all of you guys.
Thank you, Donny. It was a pleasure to have
Thank
you
you.
on board. Just on a closing note, since you are a senior developer advocate, would you like to chime in a bit about developer advocacy? Like what
Definitely.
normally comes in your role, because people have been asking much about this in the inside our
Oh,
community, but it was getting difficult to answer. So since we have someone who is in that particular shoe of a developer advocate, would like to hear more about it from your side.
okay. So that's really good questions. Thank you for whoever asking that. So the at the developer advocacy teams in for me, I'm covering ASEAN. We also have two really great guys and girls, Suman Depnath and also Rohini Konkar. They are also the developer advocate covering for India. We are helping developers to basically to transform any of your ideas and to help you understand the technologies that you can do or you can implement with AWS. So that is our main role is to help and empower developers and also nurturing community. So what I love about being as a developer advocate is that it really helps me to understand what kind of pain points, and then from there I could create like a content and also like a demos like this, in hope that I could help you to for you to build your own applications. So that's the idea of the developer advocacy. Like I mentioned that we are really open for discussion. So if you any one of you have any questions, or if you want to have just a one-on-one meeting with me, just contact me, just reach out to me, and you can also reach out to the to Suman and also Rohini based in India to help you out with all of your questions.
Thank you, Ronnie. It was really helpful, and probably we are going to have Suman next month to host a session
Nice.
again on
Great guy.
serverless on AWS. So probably you guys can keep up your questions till then, and we can get it answered from Suman.
Cool.
So I hope Suman is there on the chat window.
He is.
And we'll also like to thank Suman for introducing us with Donnie and helping us set this event up. So thank you. And thank you everyone for actually coming, taking some time out and coming on a weekend to attend a webinar on AWS Copilot. And since you are giving us a time of yours to reskill yourself, so as a token of appreciation, we have this quiz that's still going on. It's still up and running. So it will be there for next 3 more hours. So if you haven't submitted your response yet, do it. The link is there on the screen. You can just get it over from there, or else you can also get it from the chat window. Submit it. There are some free credits up for the taking. Just take it, right? Just get started. Don't waste your money. We are getting free money here. I'm sorry about that. I just say that
No
all of flow.
worries. That's true. That's true. That's true.
So guys, the link will be there. It will be active till 12 o'clock here in Indian Standard Time. So till 12 a.m. IST, you can submit your feedback. Suppose that you won't be able to do that, and the results will be out tomorrow evening. If you have any more queries, any more doubts, you can reach out to Donnie. His social media handles are mentioned over there. And
Yep.
along with that, if you follow Sovereign States Ponatia's LinkedIn page or our Twitter handle, we have already mentioned Donnie in all our posts, related to this particular talk. So you can also get it from there if you wanted to. So that's all from our end. Thank you again. Have a great weekend. Stay safe and take care. Bye
Take
bye.
care, guys. See you next time.